Hi guys, welcome back to Corner Exploits, and today I'll be showing you enumeration, and the enumeration that we'll be running on will be targeting a Metasploitable machine. Now basically, whenever you are doing a penetration testing attempt or an ethical hacking attempt on any system, you need to have physical access to that system, and so in my case I have run the Metasploitable 2 machine in a virtualized environment. This means that whenever I'm targeting this virtual machine, it's almost like I have physical access, either hardwired access or I have wireless access to that network. So the first thing whenever you're doing enumeration is to make sure you know your IP address. Now my IP address is 10.0.2.5. So the next thing, if you are doing enumeration, is to ensure that your target machine or your target system is within the same subnet. Otherwise, if it's not in the same subnet, you will not be able to access that. That's because of how switches and routers are built. However, if you are going through a router, it's slightly possible if the system administrator has set it up well. So I'll do a net discover. So this is my target system. I'll clear this up, and the next thing is to run Nmap on that specific machine. So I'll start with a version check across all the possible ports to ensure that even if the system administrator has decided to be a little tricky by maybe anonymizing most of their traffic by directing it through different ports, I'll be able to see all of that. It's always possible to increase the verbosity to ensure that you have more feedback of the process and to be able to see exactly what your code is doing and how it's executing. And almost immediately you can see we've already started discovering open ports on our remote machine. They are all running on TCP protocol. This is the Transport Communication Transmission Control Protocol. There is also another protocol that is used for data transfer. That's the UDP, the User Datagram Protocol. For Nmap, under default conditions, if you haven't specified the total number of ports that you wish to run through, Nmap checks the first 1000 pre-configured default ports. By this I mean that, for example, looking at port 21 or port 22, port 22 runs SSH, port 21 runs FTP. If the system administrator decides to move from port 21 maybe to port 19 and the FTP service is running on port 19, if you scan without limiting Nmap and ensuring that it checks all the ports, it will not see that. It will assume that there is no FTP service on that system because port 21 will not have FTP. So now that that is completed, we can see, let's go back to port 21. You see, yeah, it runs FTP 22 SH. You can see the version. You could always manually confirm this. So for example, let's try telnetting into port 21. You see, it already tells you the version, and if you go back to your control, no, if you go back to your initial results, you see it runs exactly the same version 234 of the VSFTPD. Now this will take a while to cancel, so let me close this, start up a new terminal, and let's try scanning for UDP ports. Now let's scan for UDP ports. On our remote host. Sorry for that. It's 4, not 5. Let's increase verbosity to ensure that we have more feedback on the process. As I had earlier notified you, without configuring how many ports you want it to run through, it checks through the first 1000 pre-configured ports. And you can see we've already discovered a port 137 UDP. There's a delay on the system, but it should provide all the necessary results in time. Again, UDP is a little slow, but once this process is completed, it should provide sufficient feedback on all the specific ports. And I can show you another way to get a little bit more information on the same. So let's ask for everything on that port. And now, let's say you want to provide an output of the information that Nmap is giving you. You want maybe to document for your boss, whoever has hired you to check their system. How do you go about that? There's an output application that gives you in XML, and once it's in XML, it's easy to convert that to HTML, and once you send that to someone, they can easily view it through a web browser because it's already designed such that Metasploitable 2.xml. It's already designed such that whoever is doing it will understand it so much easy. To open. Sorry, let me touch. Now that this is created, next thing, let's run the Nmap scan. Fill to open XML output file for root. Damn it. Sorry, I misspelled that. Desktop. So it should write into this file, and once it's written there, we'll convert that into HTML and we'll be able to view that through our web browser. OS Linux version 2.6, either between 0.9 or 0.33. It tells you the platform I'm running on. It's clearly a VirtualBox OS, and this is the assigned MAC address. Going further, gives you the clock speed, so much information. And now that our information is in XML format, this is clearly very difficult to read. So I'll clear this up and I'll show you how to convert that. There's a software in Kali Linux that goes by XSLTProc, and you simply give it the file name. So root, we're in the exact same folder, so I'll do that. 2.mstp, so XML, and my output, I want it in the exact same location. Store mstp 2.html. See? These are the scan results, and you see they are very well arranged, ordered. The port, let's say port 21, it's running on TCP protocol, it's open, it's not restricted in any way. The service running there is FTP. The reason is seen, acknowledge. Like I said, the TCP protocol requires that every single packet receives an acknowledgement, in that whenever it's received, whenever it's sent, there is a confirming message for each of that. All these ports, whether they are open, services running, if there's the ability to log in, if there's a shell, and this comes in very handy, especially when you're doing penetration testing, because for any open port which you have the login probability, or you can telnet into that port, or you can go into secure shell to the same port, is always a loophole. These are the things that hackers are always looking to exploit in any form of sophisticated system. And whenever you are preparing your report, this will come in very handy for you. Now a quick assistance on the side is on Zen. Nmap does exactly the same thing we've done. For example, let's do a simple scan on the system, 0, 2, 4, and a discovery. Let's do a ping scan of our target system. And you've also noticed that Nmap and Zenmap, despite the fact that they run the exact same commands, Zenmap is very graphical, which means you don't have to cram all these commands, all these simple services, maybe for the ping scan, the network discovery, whether you want an intent scan or UDP. You see how much verbosity you require, depth, how much information. Zenmap will do all that for you, and it will also allow you to customize what kind of code you're running, or what kind of request you want to run. You can see it tells you that one IP address has been discovered and the host is up. So for example, maybe you wanted a quick scan, or no, let's do a trace route. Tells you that it's done, tells you the IP address, how long it took to get there, and how many hops. Now in networking, when we say hop, it's about how many networks or how many switches or routers do you have to go through to get to that specific machine. Now in this case, because the two are exactly on the same network, it's just one hop. It's from my Kali machine into the Metasploitable machine. Thank you for watching. Kindly hit the like and subscribe button, and onwards as I go on with this series for Metasploitable and running the capture the flag challenges. There will be so much more to learn, and it will be a very interesting trick, and it will be very good. So kindly hit the like and subscribe button, and see you next week.